Hello everyone, welcome to today's class. We'll be looking at set theory. Today in this class, we'll be looking at introduction to set theory, just looking at the basics of set theory. But before we go back to the board, I want us to picture something that we do see or mostly see every day. Let's talk about cars. You see, if you ask me today that do you want a car? I may ask you which type of car. Are you talking about Toyota? Are you talking about Lexus or Benz or any other type? So when talking about cars, car has different brands. Okay. So if you ask me which type, do I want to buy a car? I will ask you which type of car because they are brands. So we cannot say that all cars are the same. You understand? So I can tell you that we have different cars. Let's say car A belongs to Toyota, car B belongs to Lexus, and the rest. So we are classifying those cars with respect to their brands. I don't know whether you're understanding. We are classifying those cars with respect to their brands. So that classification is what we call sets. Let's talk about students. We have different types of our pens. We have pen with color, with black ink, with red ink, and the rest. So if you ask me, do you want a pen? I will ask you, which pen are you talking about? Because I don't use blue pen. I use black pen. You understand? So this pen can also be grouped with respect to their ink, the colors of their ink. So this is what we call set, classification of certain objects with respect to their characteristics. Now let's go back to the class. We have a question here. Okay, let me just write the question down. Let's say we have a question asking us what is a set. This is a very simple question, and I believe some of you can answer it from secondary school knowledge. Okay, so by definition, we can say that a set is a collection of well-defined objects. Please, I want you to pay attention to some things as I'll be explaining it one after the other. Let's read the definition one more time. We say that a set is a collection of well-defined objects. In this definition, I want you to master two major words. Here we have collection and we have a phrase, well-defined. I believe you know the meaning of collection, right? To bring things together, to collect things together, okay? Now, talking about that car, if you collect a certain brand of car together, let's say Toyota Camry, Toyota Corolla, it still belongs to what? It still belongs to Toyota, our brand. So that's collection of a number of cars, okay, that belongs to Toyota brand. Now, talking about this phrase, well-defined. As I said earlier, if you ask me, do you want a car? Or just bring me that car. Which car are you talking about? Are you talking about Toyota or Lexus or Benz? Now, talking about well-defined, you can just tell me that, give me or go and bring me that Toyota Camry. Which Toyota Camry? The one with what? With red paint. You understand? With red color. So that is how we define that set. And it's been defined explicitly in the sense that if you see it at the first glance, you'll be able to identify this is what I'm talking about. That's the meaning of this well-defined. Let's take another example. Let's say in the whole town of Mina, I just ask you, okay, go out and go and count the number of tall men in the town. You feel it's somehow easy to do, right? But let me tell you, that's not an example of set. Why? It is a collection, yes, collection of tall men, but it is not well defined. For instance, if some of you see me, you say I'm a tall man, okay? If some see me, they will say, oh no, this guy is very, very short. Why? Because the level of tallness is not well defined. So when talking about set, a set is a collection of well-defined objects that are explicitly explained. The characteristics are explicitly stated. For instance, let's say that let's have some examples of set in mathematics. Okay? Examples of sets in mathematics. Pardon. So, let's say we have set A, and set A is it has the following elements. We have 2, 4, 6, 8, and the rest. Okay? If I should explain this, I can simply say that set A is a set of even numbers. Okay? These are set of what? Even numbers. These are explicitly stated. You know the meaning of even numbers, right? Numbers that are divisible by 2. So these are what? This is an example of set. But let me say our set B is a set of odd numbers. Okay? I believe you will not tell me that 6 or 10 is an example of odd number. So if you see odd number, you should be able to identify this is an element of set B. So those are the examples of sets in mathematics they are collection of things, and the things are explicitly stated. The characteristics are well explained and they are well defined. So these are just little examples of sets, or example of sets in set theory. Now let's look at the way we write sets. The way we write set. For instance, okay, let's say this is an example of set. You can see me writing A here. You can see me writing some letters here. I mean some numbers. Now, if you want to write a set, we have what we call element of sets. When talking about element of sets are just the members of that set. Let me write something here. Let's say we have set X to be this. Let's say we have A, B, C. Now, this X is the set. While these are what? Are the elements of the set. The element of the set. So this is what we call, this is what we use to represent the set. We use capital letters to represent set and small letters to represent the element of set. Why? Each of the elements is being separated from the other using a comma. This is how we write set. And for set, we use what we call curly brace. We use curly brace. Curly brace or curly brackets to denote set. So you cannot just use regular bracket that we know like this or large bracket that we know. You don't use this. So this is how we write set. And don't forget, I call the members of the set what? I call it elements. And we still have something called cardinality. Okay? Let me write the element out. We have element of set are the members of the set. Okay? And we have what we call cardinality. Cardinality is the number of elements in a set. Okay? So let's say this is a set X. The element of this set X are A, B, and C. While the cardinality is 1 to 3. We have 3 elements in this set, and the cardinality of this set X is equal to 3. That is what we mean by element of set and cardinality of set. Now, let us talk about fundamental laws of sets. You know, in Nigeria, we have laws, we have law guiding everything we are doing as citizens of Nigeria. So in set theory as well, we have some laws that guide how we write sets and things we do in set theory. Let's say, for example, I have this set A is equal to, let's say we have the element of the set to be 1, 4, 3, 3, 2, 1. Okay? This is an example of sets. But some people will say that the cardinality, from what I explained earlier, that the cardinality of this set is 1, 2, 3, 4, 5, 6. Some will say it is 6, while some people will say it is 1, 2, 3, 4. So why is this one like this? Let me just explain the law guiding how we write sets. So we have 2 fundamental laws that guides writing of sets. Okay, the first one states that there is no repetition. There is no what? There is no repetition. What does this mean? Let's say that I have a set. Okay, let's say we have set A to be 1, 2, 3, 5, 8. Okay, and set B to be, set B to be 3, 2, 4, 9, 1. Okay, so if somebody asks us to write A and B together, set A and set B, to write it together, some will write it like this. Let's say from set A, we have 1, 2, 3, 5, 8. And from set B, we have 3, 2, 4, 9, and 1. Now, to write this, to rearrange it, we can have this thing. So we have 1 here, we have 1 here again, we have 2 in 2 places, we have 3, 2 places, we have 4, we have 5, and we have 8 and 9, if I'm not mistaken. So here you can see that we have 1, 1, we have 2, 2, 3, 3, 4, 5, 8, and 9. What this law is telling us is that there is no repetition. In case of this 1 and 1, what you're supposed to write is equal to, it's supposed to be 1 out of this 1 and 1. For these 2 as well, we have 2 in 2 places. You are only allowed to write 1, 2. 2 like this. And this one we have 3, we have 4, 5, 8, 9. Do you understand? So this one is equal to this. Now, if I give you this one, let's say the test or our assignment, and I ask you that what is the cardinality of these sets? If you go ahead and say we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, I'll just mark you wrong. Now, what is the exact cardinality of this set? It is 1, 2, 3, 4, 5, 6, 7. So the cardinality of this set is simply 7. So this is what we mean by saying that there's no repetition in set, in writing set. There's no repetition. Please permit me to clean all this. There's no repetition in set. So to just drop one example, let's say that if you are given something like our set A is equal to 1, 4, 2, 8, 2, 1. This is the same thing as 1, 4, 2, 8. What about these 2? It is here already. What about this one? It is here already. So there is no need to repeat any element of the set. So this and this are the same. Going to the law number 2, we have the law number 2 states that just hold on. Number 2 states that order does not matter. Order does not matter. What does this mean? Let's say we have set x equals to 4. You should be wondering, why am I just falling in love with 4? Just don't mind me. I like 4. So let's say we have 4, we have 6, we have 5, we have 9, we have 10. Something like this. So we'll be asking, why is it not written in ascending order or descending order? Here, order does not matter. If you look at this one, you see that it is going up here. It comes down to 5, went up again. So the order with which we write set is not a matter to be put into consideration. I can tell you that this thing is still the same as, let's say we start with 4, 5, 6, 9, and 10. Understand? So what I'm saying is that the rule number 2 states that order does not matter in set theory. So you can arrange it any way you want. If somebody writes this one as a set X, is correct, together with the person that writes X as this, because they are of the same element, just that the order are different. And in set theory, order does not matter. So dear friends, this is where we are going to stop for this lesson. And as you can look at the board, you can see some exercises to be done. Exercises, my bad. So try and answer this question. Number one, explain what you understand by the following terms in the context of set theory. What are elements? And what is cardinality of sets? Number two, give different examples of sets in your immediate environment. If you look around you, your house, in your town, in your classroom, everywhere you find yourself in your environment, what are the examples of sets you can see? The collection of well-defined objects. Let me see your answers in the comment section. Thank you very much and see you in the next class.